So for today, we are very happy to have to feature the work of Dr. Siqi Zheng. The presentation titled "The Emotional Toll of Climate Change and COVID-19." Dr. Zheng is a professor at the Department of Urban Studies and Planning and the Center of Real Estate in MIT. She established the MIT Sustainable Urbanization Lab, and she was also the former president for the Asian Real Estate Societies. And she is a board member of the American Real Estate and Urban Economics Associations. And she is also the associate editor for China Economics Review, Journal of Regional Science, and Journal of Economic Surveys, and is on the editorial board of Journal of Housing Economics and the Journal of the American Planning Associations. So for today's presentations, she will report their latest work uses natural language processing techniques to construct a sentimental index from social medias. The sentimental index are also linked with the extreme weather conditions and the COVID-19 shocks to quantify their negative impacts on people's expressed sentiments. So the work explores heterogeneities across countries and different population groups and the underlying mechanisms. So without further ado, I will turn the screen to Dr. Zheng.
Thank you so much, Weijia, for your very generous introduction. It's my great pleasure to be here and to present our ongoing research project. I will share my screen. Okay, can you see my screen?
Yes, it looks
okay,
good.
Great. Yeah, I will get started. So today I'm going to talk about our ongoing project in my lab. As Weijia just introduced, I established this Sustainable Urbanization Lab at MIT. And our research agenda, basically, as you can see, is the sustainability in the fast urbanizing regions and all over the world. So here is one of our projects in the lab called Global Sentiment and Climate Change. And we use social media. We use social media data and we use the natural language processing to extract information from the social media. And we then link that to all those like climate risks and COVID shock and other adverse environmental factors to examine how that will lower people's happiness. That we call it emotional toll. So this is a teamwork with me and Nico in our lab as a computer science researcher, and Jiang Haowang from Chinese Academy of Science. He was a former research scientist in my lab, and Huan as a research associate, and Yichun as a master student. So I will briefly talk about our journey. Our journey from at first, we did some China studies, and then how we expand this research framework to this global scale. So back to 2016, we started this direction of research, and then we published our paper in 2019. In that paper, we focused on China. We used the Chinese Twitter, Weibo data, and all those geo-tagged more than 200 million geo-tagged tweets in 2017. For every post on Weibo, then we use natural language processing to construct such a sentiment index, express the sentiment on social media from 0 to 100. And then the 0 means very unhappy and 100 is very happy. And then we link that to the air pollution, a local pollution. As you know, Chinese cities, many of them, they have very high level of pollution. And then we immediately observed such a negative correlation between pollution and people's happiness on social media. And then we also did a lot of heterogeneity analysis and mechanisms to show this emotional toll of air pollution. And then, then we have, good, such a very good approach. Use social media data to study this adverse impact of those environmental problems on people's subjective well-being. How about we try another one? Then we did another paper, also still use the social media data in China, and the same why. The Y variable on the left-hand side, same. The sentiment index on the right-hand side, this time we controlled for air pollution as a control variable, but then we told another story about these extreme weather conditions. Very hot days and very cold days, whether people feel unhappy. And as you can see, that we also had some very interesting result. Basically, people feel the most comfortable and the happiest when for the very most comfortable temperature, which is about 20 to 25 degrees Celsius, which is consistent with other studies from other countries. And in very hot days, it's a drop. Very cold days also a decline. And on hot days, this side, a larger drop. Why? Because the penetration rate of air conditioning in China on average is still low. So people don't have enough adaptation strategy to cope with the very hot weather. But for the cold side, especially for the north part, which is very cold in the winter, in China has this subsidized universal heating, winter heating system, subsidized. Everyone has, no matter whether you are poor or you are rich families. So that's mitigate to some extent the negative impact of cold weather on people's sentiment. And then we also did forecast for the next 30 years, 80 years of climate change will increase the frequency of the extreme weather conditions and how that mean for these people's subjective well-being. After these two exercises, we thought about, okay, we learned from the literature the social cost of climate change from all kinds of aspects. For example, economic growth, food security, increased risk of conflict, and etc. And of course, health outcomes. And also now some new papers recently have started to look at this climate change, not only impact all those economic and health aspects, but also the psychological well-being of people, whether people feel happy or not. And they already find some they already find some like evidence from the developed countries, such as US and Europe, with good data, but they have not extended to developing countries. However, as you know, that with the fast urbanization, more and more people, they are living in developing country cities, and the climate change will have a much larger effect in those very high density places in developing countries. So we want to further extend to not about China, but use our this framework to study a global scale, both developing countries and the developed countries, and see the difference and the commonality. So that's a motivation. And then, of course, when we extend to all other countries, we cannot use Weibo, which is only the social media data in China. And ironically, Twitter is blocked in China, so that we could only use Weibo in China. But when we look at other countries, we really need to use this universal, more like applied this social media platform in other countries, which is Twitter. And then we work together with our partners, especially the Harvard University Center for Geographic Analysis, to get the Twitter data from them. And also we also extract from by ourselves. So now currently for the later papers, we use the Twitter data of 2019 and 2020 and 2021, especially 2019 and 2020, now extend to 2021, and to study this climate change and the COVID. So we got this geotagged social media data, and then we start our data analysis and modeling. So we use natural language processing, and we produce this express segment. Now we're already very familiar with the technology now. And then we also collect all the data from the climate events, heat waves, flooding, and hurricanes or wildfires, etc. Then we also have a lot of other environmental controls. So now we are going to ask many questions, not just one, happiness, but happiness is the basic, the first step. So we want to understand what are the effects of the natural disasters on the psychological well-being measured by this expressed sentiment on social media. And then we also want to understand one step forward about their belief in climate change. And how do people talk about climate change? Whether they are climate believers or deniers. What's their attitudes towards climate change? So as you can understand, even if people really respond to the extreme weather conditions, hot weather, hurricane, and etc., this kind of their unconsciously, they feel unhappy, unhappy because of the shock to themselves. But maybe some of them, they don't believe in climate change. They think that's basically unlucky. They have these disasters happen to them. But we really want to understand, to measure their belief. And then based on that, we will see the behavioral change. What is impact on the real life outcome, not just on their mind, but also their behaviors. For example, consumption and their hope values and their migration behaviors, etc. So that's kind of our 3 steps. First one, sentiment. Second one, what on their mind. Third one, what they're gonna take action. So of course, this is ongoing. So today I'm gonna talk about the first step, still this sentiment, but we extend to all other countries. I will quickly go through all these steps from the data collection and sentiment measure construction and the econometric modeling and some results. And I will also say, okay, in 2020, when we were doing climate change, then COVID broke out. We thought, okay, COVID is another example of the negative shock to people's happiness. And then we also have a side project on COVID, which basically we share the same data infrastructure. So first step is to extract this information from social media, Twitter. And now we are using this, we know that as many of you are familiar with this natural language processing, 2 major categories of approach. The first is dictionary-based approach. They have these sentiment dictionaries, this hedonimeter. It's just positive and negative sentiment. And the LIWC is more sophisticated. They have like 5 to 7 of this sentiment, like not just the happiness, but also anger, anxiety, etc. So anyway, they have dictionary, and then you can apply those dictionary to detect all these words in the post, and so that to construct the sentiment measure. And this is good. In my previous papers, we used this approach. But now we are using this like machine learning, more advanced machine learning approach, especially this recently developed language model, BERT, by Google. For this one, they don't have a dictionary. They use this machine learning to figure out the sentiment component in the post, which is good because, for example, for some new words like COVID, if you don't constantly update your dictionary, so it's hard to detect these new words. And also this BERT is the good thing is it can handle multi-language model, like currently 104 languages, which is super useful when we are doing this global study. So that's why we chose BERT. And so BERT basically, for the technical details, I won't dive into, but just at a high level, it provides more than 700 features for each post. Then from all these more than 700 features, it can extract these features of value of this a sentence, a post, and then kind of you can do this principal component analysis to get the major components you really want. For example, this is like 2 clusters of this when we currently are doing this still like happiness, there's positive and negative sentiment from the principal component analysis from all the 700, we further aggregate into 2 now, which is positive and the negative sentiment. And the good thing is, for example, for these 2 twins, they are totally different in terms of the exact words they are using, but they have the same content, the same content, which means they both like this movie, and they like the movie and they enjoy the movie, although it's no word the same thing. But from the BERT, they can do the same thing. Then they just classify these 2 twins into 1 cluster, which is a positive cluster of the sentiment. And then, then we have the two clusters, but how can you know which is positive, which is negative? The previous step, you only put all the similar twins into one cluster, but still you don't know whether this is positive or negative. Later you will know, but how do you know? So this is a trained sample. We got the trained sample, meaning like linguists, they have this trained sample and they already manually labeled those trained sample of it's positive and negative. That's this red and blue dots. And then we use a trained sample to further train all these other posts so that all the other posts, we define them as positive and negative. So I think that's a basic idea of this machine learning algorithm from the trained sample and then expand to our entire sample to identify the two major clusters. After this, for each tweet, we have a label of the positive or negative. Then we're gonna start this. We're gonna start this and link currently to the temperature. So then currently our unit of analysis is we are doing global starting. Our unit analysis is one level below a country. For example, the United States will be the states, and for China will be the provinces, and for other countries, basically one level below. So we have 3,558 such one level below. We call it admin 1 regions. 3,558 such regions. And we aggregate our sentiment measure of the twins into this admin 1 level region and the day level. So basically 365 days. So that's our sample. And so that's our sentiment measure at this region day level. Of course, we can do individual, we can do any level of this aggregation, but now we are looking at this. And then we also collect all this data, maximum temperature by this region day level. So for now, our econometric modeling, we are doing this for 2019. And for 2019, we have 1.3 billion tweets from all the countries. And then we aggregate into this region day level, and then we merge with the temperature with all the other control variables. And overall, I will show you some results. Overall, when we look at the global on average as a one model, clearly extreme temperatures will lead to a drop in sentiment. And here is a very hot days, higher than 30 degrees Celsius, and very cold days below 10 or 5 degrees Celsius. You can see a very clear decline of the sentiment. For example, this extreme very cold days more than, this is a percentage of the standard deviation, more than 20% of the standard deviation drop, and this side is like 15% of standard deviation drop. So I need to mention one thing which is very crucial, is it's very hard to directly compare between countries because of cultural difference, because people's language, and because all this local contact. It's very hard to say we have a absolute value of the sentiment, then we do country to country comparison. This country is more happier, that country is less happier, because they have their different habit of expressing their sentiment on social media, and plus all the local differences. That's why we standardize at the country level. We look into the within country difference. For one country, we just standardize using the mean and standard deviation to standardize one country. Within country, these subunits. And then this enables us to do this between country comparison after we standardize at the country level. That's a very important point to mention. Okay, and then after we do this global model, we also try these different climate zones, very cold zones, very hot zones, and because they are in different like temperature range, this very regular temperature range, and you can see this different. They generally follow the same pattern, although they are basically their temperature are in different ranges, relatively cold, relatively hot, but in general, they follow the same pattern of this inverse yield curve. And of course, we can do different countries. And we do this for Canada, and for Brazil, and for Japan, and for East Europe country, there's Belarus. It's a East European country which close to Russia as a very cold country. So just want to say that, show that in general for every country, we also find a similar pattern, this inverse U. But in some places, for example, very cold country, maybe like this hot days not that bad, because they always they're so cold. For some very few very hot days, the sentiment won't drop that much. But however, I need to say that for this extreme weather bins, always the sample size shrink a lot. So that this standard error is so big, it's very hard to tell because the standard error is so big. But just want to let you know that different countries, they differ a little bit, but they share a similar pattern. And then we need to understand, we still want to, based on this, when we understand the patterns, to do a model to further review the patterns. So now we choose to compare the countries on this. So always we use this 20 to 25 degree bin as a default. Then 2 bins to the right, which is this 30 to 35 bin, and then the sentiment drop. For example, this is like an increase, but for most of the countries, there is a drop. And then we measure that coefficient as a drop for different countries. Then we have country-specific coefficient at that drop. We call it a sentiment shock due to the very hot weather. Then you can see that for those countries, some are big drops, some are relatively small drops, and some like a small increase. But for those countries, because of the constraint of the sample size, is a big standard error. It's not like a statistically different from 0. But for many on this side, it's really very clear, a very significant drop. And 1 or 2 countries, significant increase. We still face this sample size issue, and because we currently only use 2019. And we are working together with the Harvard Center to extend our sample size to multiple years. Finally, I want to show you another exercise related. The Y variable is still the same sentiment, but the X variable, we replace this, not replace, we control for all the temperature, all the climate factors, but we started COVID. That's very timely topic last year. And we use the same strategy to construct the sentiment measure. And we started this COVID impact on people's sentiment. That's all the countries. For this sample, we use 2020, January 1st to the last day of the May. That's an outbreak period of the COVID in all the countries from China, Wuhan here. This is China. And here is a measure of the sentiment. We also standardize at the country level. And then this relatively red ones are very unhappy days, and the blue ones are happy days. And then you can see for each country, we have a line. And then we measure the shock of the COVID. It's very clear when a country was hit by the COVID, the very peak days of the cases. And then you have this very bottom value of the sentiment, and then recover. So it's like this path of all the countries. Some countries got hit first, some countries got hit later, and also, of course, they are different in terms of the severity of the COVID shock. Then we measure the sentiment shock in terms of the standard deviation of their before COVID sentiment level. Then you see some countries, they are really got hit very heavily in terms of sentiment. Some countries not. And then we also started their recovery, how time by the recovery, how long it recovered to the pre-COVID level. That's for now. And a quick conclusion and discussion. We think we are doing this kind of first global study to assess climate change damage in terms of the psychological well-being. and then we can compare the different countries' differences. And our next step is, of course, we need to, this is our first step, and the second step will be the topic analysis to understand people's beliefs and attitudes, and the even third step will be the behaviors, so that we can support policy, we can support the decision making. So I think that's my presentation, and I'm very happy to answer any questions and have discussion with all of you. Thank you.
Thank you very much. I think it's very interesting work, and you have done a lot of the data collection and analysis, obviously. So if there anyone has a question, please like either using the Q&A panels and to type in your questions, or you can type in them in the chat channels there, so we can read and we can see them. I will start with one first. Is so my understanding is you're using basically the standard sentimental analysis model from the BERT to do the sentimental classifications. But like, do you trying to distinguish like if the sentimental was caused by COVID or caused by other factors? Let's say like the hot weather or extreme weather itself might be have a direct impact on sentimental analysis as well, right?
Yes, this is a very good question. Yes, so basically in our team, we have like two sub-teams. One is on the computer science, which is a BERT and how to extract information of how to construct these sentiment measures. The other is econometrics team. So for that team, we focus on identification. That's to answer your question. Really, when we have the sentiment time series and how we can really identify the causal inference between a factor and the sentiment. And we have all the ways to do that. For example, for COVID, it's because it's a sudden shock. Then we have the regression discontinuity approach. And for the temperature, we have all these fixed effect models to make sure that we are doing this within a unit analysis and the control for all other variables to study this extreme temperature. So for each story, we have a way for the identification to make sure we are drawing this causal inference. You are muted.
Yeah. So how do you verify the results? Do you like have a curated training data set or standards, and you're going to verify the accuracy of the algorithms?
I think that question I couldn't answer very well because I'm not trained as a computer scientist. But I think we have the way, for example, the out of sample validation for this sentiment measure, and for the effect of this climate and COVID. Our way to verify or validate is to compare the effect with others, with other literature, with others, what they found in other countries, and to see if there's a big difference, and if yes, why. So in this way, it's kind of not a very strict verification, but we just want to see whether we get a reasonable result.
Okay, thanks.
Wait,
sure, go ahead.
Quick question, Siji. Thank you for the wonderful presentation. Very, very interesting research. Quick question. So for the sample size, how do you standardize the sample size? Because social media, let's say Twitter, is not that popular in certain country, and the penetration of mobile phone is not great. Say in some African country, you might just get the sentiment for the elite people who has a cell phone, who can afford the data, and who use Twitter. So how do you justify that?
Yes, that's also a very good question. I think that's always a limitation when you use social media data, because it cannot represent the entire population. Always like the elderly people and the kids, they are less represented. And you are looking at those middle age and who have access to the mobile, to the smartphones. So I think that's basically we couldn't do much on that. We have to acknowledge that always when we write papers using social media data. And especially another thing is for Twitter, it's very popular in certain countries like the US and Europe, but not in all other countries, especially non-English countries. We still find people there using Twitter, using their own language, but maybe they have their local, very popular other social media platform. In China's case is Twitter is blocked, so we use another one. But in other countries, Twitter is not blocked, but just because they have other popular local ones, similar ones to use. For that one, the only way we can do is to extend to more years so that we have a relatively okay sample size, but we cannot do much to beyond that. We have to acknowledge that limitation.
Another thing is not a question, just suggesting. Right now, you are doing a unit of analysis at level 1. So in that case, I think each unit probably had enough Twitter from that unit. But if you go down to a fine scale, maybe you will find that Twitter, the location of the Twitter is not from that unit. Some unit will not have enough social media account in that region.
Yeah, that's true. If we want to have a specific location, especially within a city, that's become very hard. But however, I think that's a trade-off. If we do global, we stay at the relatively aggregated level. If we want to go into a city, then we tell a story of a country or a city. And so that we look at the cities with enough Twitter data or Weibo data.
Yes.
Thank you so much.
Very good. Very good.
Thank you.
Good research, very meaningful research. Thank you, Steve, for sharing that.
Yes, actually, why I came here to present, of course, because Junfeng is my good friend, but also because we want to seek collaboration. Because as you know that we set up this as a big project, and we are doing this like the preliminary stage number, first stage, construct data and do a global sentiment, and then we have a lot to do. So I'm here to find collaborators and who are interested, and this all the open source data of Twitter. I think that's how it's very easy to work together on specific topics.
Yes, we have Weijia is the data manager for Texas Supercomputer Center, and we're very interested in the research. We're certainly very happy to work together on this for the future projects. We can talk more on that.
Yeah, I really look forward to that, Weijia and all of you, how we can set up specific topics as a project.
Yeah, so we do have our own Twitter collection since last January all the way to middle of August, like about half year, and we and then we have run couple of like a top level NLP analysis on some other projects as well, but we didn't run any of the sentimental analysis before, so it might be interesting to talk something more on that in the future.
Thank you. Yes.
And there are a couple of the other faculties in the UT, I know, like they do the Twitter studies as well. And maybe that's if you can share with us your slides, and we can also posting through our website, so there's maybe more people can take a look.
Definitely. I will share the Google slides afterwards.
Okay.
Okay, thank you.
Thank you very much. So now we're actually 5 minutes over the 10:30. So I want to thank for Dr. Zheng again for this wonderful talk and give us the opportunities for this, and thanks for everyone who joined us. If you are interested to learn more about the smart cities and our future events and the talks, and please feel free to visit our website, which I posted in the chat. Our next, we have another event on the next Tuesday at, from Dr. Zoltan Nak from the UT Austin as well. So thanks everyone, and bye.
Bye-bye.
Thank you.